Okay, hello and welcome to Math 8, Unit 4B, Lesson 4. Today, scholars will find the volume of composite figures. Composite figures. Okay, so let's talk about first, what is a composite figure? It is a figure made up of different shapes. Here, I have a rectangular prism with a hemisphere cut out of it, where a hemisphere is just half a sphere. Half a sphere is a hemisphere. Here I've got like a rectangular prism with another rectangular prism added on. Here I have a hemisphere and a cone. And to find them, we just add or subtract the volumes of the different areas. Okay. So how can we find the volume of a composite figure? So first we have to figure out what shapes they are. Here I have a cone. Here I have a hemisphere or half a sphere. A hemisphere. So I know my volume for my cone is 1/3 pi times my radius squared times h. My volume for my hemisphere is going to be half a sphere. It is, instead of being 4/3, it is 2/3 of pi times my radius cubed. So these both have the same radius of 6. So here my cone, his volume is 1/3 times 6 squared is 36 times 15 times pi. So I have 15 times 36. 1/3 of that is 100. So this volume is 180 pi. Okay, down here my hemisphere, and I'm going to say a different color just so you can tell, is 2/3 pi times our radius squared. Again, my radius is 6, so my volume is 2/3 of 6 cubed times pi. 6 cubed is 216. So our volume equals 144 pi. Again, I'm just going to add these. So when I add these together, it's just going to be 180 pi plus 144 times pi gives me a total of 324 pi. Again, we can multiply those out to find it, but that's our total volume. We just add our two volumes together. So let's look at this. Here, I have, again, a hemisphere. So this one, again, our volume is 2/3 pi times our radius. Radius cubed. But here, I have a cube. So its volume is simply 8, or simply the side length cubed. So let's do that one first, because that's really, really easy. Our volume is 8 cubed. 8 to the 3rd power is 512. So that one was really, really quick and easy. So let's go up here to our hemisphere. First thing we need to figure out is what is our radius. So our radius should be from here to the edge. This whole distance is 8. So 8 divided by 2 gives us a radius of 4. So this is going to be our volume is 2/3 of 4 cubed times pi. 4 cubed is 64. So our volume is 2/3 of 64 times pi. So it is 42.67 pi, which gives us an approximate volume of 133.98 pi. So we're going to add, not pi, that's gone. We put the pi in there. So it's just 133. So now again, we're just going to add these two. So I've got 133.98 plus 512. We line up our decimals. So the 0.98 comes down. This is a 5, a 4, and a 6. So that is our volume, and it is in cubic centimeters. Let's try. Okay, so this one's a little different. You'll notice this is a cylinder. This is a cylinder. Volume is pi times radius squared times h. And then we have a hemisphere, but the hemisphere is not added onto it. It's taken away from it. Like they dug out this hemisphere. So again, our volume for our hemisphere is simply 2/3 pi times our radius cubed. Okay, so let's do our two different ones. So here my radius, our diameter is 6, so our radius is 3. So our volume is pi times 3 squared times 11 is our height. So 3 squared is 9 times 11 pi times 9 times 11. So that gives us a volume of 99 pi. And then up here, our volume for our hemisphere that, again, we are subtracting is, again, our radius is 3. So our volume is 2/3 of pi times 3 cubed. 3 cubed is 27. So our volume equals 2/3 of 27 times pi. 2/3 of 27 is 18. So our volume equals 18 pi. So again, in this case, because the hemisphere is scooped out of it and it's not added to it, we're going to subtract. So I've got 99 pi minus 18 pi, which gives me 81 pi. Again, I can multiply that out. 81 times 3.14 to get an approximate volume of 254.34 cubic inches. Okay, one more problem. Okay, real world. So this is a silo. So let's look at this real quick. A hemisphere is 1/2 a sphere. The top of the silo is a hemisphere with a radius of 12 feet. What is the volume of the silo? Round your answer to the nearest thousand. Not thousand, thousand. Okay, so this radius here is 12, which is also this radius here is 12. So we need to find this height here for our cylinder. Well, the entire thing was 52, but if we subtract the 12, we get 40 as our height. So let's start out doing our cylinder first. So our volume equals pi times 12 squared times 40. And again, you can just put that whole thing into your calculator. So 12 squared times 40 times 3.14. 12 squared times 40 times 3.14 gives me a volume for my cylinder of 18,086.4. 18,086.4. So then we go to our hemisphere part right here. Put this over here. Our volume, again, is 2/3 pi times our radius cubed. So again, that's going to be 2/3 times 3.14 times 12 cubed. Put that entire thing into your calculator. So that gives me 3,617.28. Now I'm going to add these. So I've got 18,086.4 plus 0.28 here, 716. 3. So I'm going to add these up. Which gives me 21703.68, but we're rounding to the nearest thousand. So that is this place right here. So I see the number after it is a 7. So as you go up, so this is 22,000 cubic feet. Okay. Go ahead and try these in class and let me know if you have any questions.